Hello! For this third part, the topic is more on error handling of the axis mainly, and also to see how can we extract data. In previous video we saw that we ran into some faults on a drive, but now to visualize them and to see how can we get rid of those. We will start with our visualization. Just to make it a bit nicer, we will put one right angle all over, right click, we will send it to back, and then in properties we will change the color of normal state, fill color, we will use, let's say, orange. Okay. So we have our frame, and we will now rearrange a bit where we want that our function blocks are on the right side. Let's move velocity down. Or maybe, yeah, doesn't matter. Let's put MC stop down. Let's put MC move velocity here. MC power we will put here. And this left side we will use for additional thing to visualize states and faults from our drive. First of all, we need to see how can we reproduce certain error. And then let's see how can we get rid of that error. So first of all, to get rid of the error, main function block is MC reset. So let's put it here. MC reset axis 0, 1, 2 dots, F2, MC reset. Okay. Let's call it in our motion function blocks. F2 instance call MC reset axis 0, 1. Okay. Let's put everything in one line. And let's make this a bit different. So first of all, spell checking. This should be capital. Let's put it here, also capital. And now let's align these function blocks that we have. Put everything in the same line. Let's use one more tab. Just that it's more clear when we try to copy paste the axis which we use. Okay. Now what we need is axis. And we need it here. So this is our call of the function block MC reset, which we will use. Again, go to toolbox, select the frame, MC reset. Okay. And we need to connect with our instances in our application. Okay, let's try to load our program first. Okay, log in. And let's try to simulate some error to see how can we reset this error. So easiest is to simulate the following error. Following error is simply error which happens when the drive cannot follow the reference. And in this case, we are talking about the position reference. So let's try to enable the drive. Okay. And now we put something here extremely big for velocity, acceleration and deacceleration. What will happen is that we will provide such a high velocity and such a big ramps that simply reference is going to move forwards much faster than the actual position of the motor, which will cause following error. However, this can be very aggressive, as you will see like a jump of complete motor. Let's test this. Okay, you see, we had even few rotations there, and we have A320. So this is a following error. And now if we remove execute, and if we execute reset, we can reset our drive. Clear. But now we want to import this following error in our software. How to read this error from the drive. So let's log out and let's enter our Lexium 32M drive. Process data. And here we see is drive error number. This means that we can use this automatically. We just need to map it. So let's go to IO mapping, drive error number. Let's call it IUI because it's unsigned integer. Input 01 drive error. Now let's try to visualize this. Go to visualization, open toolbox, go to common control, and then use a text field. Let's move it here. Now in this text field, we can put text, which says drive error, 2 dots, %x, and this will display hexadecimal value of our register. A320 is in fact hexadecimal value of this register. So if we go to text variables, now we need to select, and it's now here in our config global mapping. Okay, enter. Let's just align text to left. Okay, excellent. So let's log in and see if we can see some error here. Okay, we will reproduce the same procedure. So first run the PLC. Let's test our A320. Regulator on. Again, some extremely big values, just that we reproduce. Maybe even 10 more. Okay, violent movement, here we go. We can see that our error is really A320. So we know now how to get this error from the drive. If we execute, we see it's gone. Excellent. Now, what is also interesting is some of the things which are inside your axis, inside your function blocks. You could see that here on MC move velocity, we have error and we have error ID. Now, where is this error ID located? This is inside an axis. So if we now try to trace an axis, let's open it up and let's repeat the same. Okay, we have error 35. If we go to our axis first, we see that we have some function block error, SMC DI axis error. So this is one of the things we also want to display. And where is this located? If we open our axis, there is an FB error. And we see that this is an array of 6 structures. And this is showing which error is it. Furthermore, this is chronologically inputted data where 0 is the oldest error and 5 is the newest error. So how will we do that? First, disable the drive for the moment and let's log out. We would need a table we click properties. On the data array, we go config global axis, and then we find our FB error. We click OK, enter. Now we only need this ID, so we will disable everything else. And we will change this to FB error. Enter. Let's now take this and make it a bit larger. And immediately we see that we have certain values and almost everything that we need. Let's move it a bit. And here we will have our error displayed. Okay, so now is the time to test this. If we log in, immediately we see that this is filled. Now, what is the difference between the axis and the drive error? If we click reset, we see that this buffer is completely empty. However, if we, for example, execute reset again, we will get a fault which says no error to reset. Okay, if we remove and reset again, we see that this buffer is not emptying itself. If we, for example, execute some function block with invalid data, like deacceleration 0 and MC stop, we get an error. And again, here we see there is an entry. So here we can now add a lot of entries, but at the end this buffer is going to be full, and at a certain point we want to empty a buffer. For this, we have one function which we can call, which clears the oldest error. Function that we need to call is called smc clear FB error. First of all, we would need to create some variables. For that we need to log out. So let's create one boolean, which is b, for example, clear FB error, type bool. Okay. Then let's create function block type of rising edge trigger. So FB or trig clear FB error type of R trig. And let's now comment this FBs. Okay. Now what we need inside our communication to clear this error. First of all, let's call our function block, instance call. Okay. For clock, F2, let's put our be clear error variable. Okay. And now let's put a condition. If FBR control space dot Q, then, and now the function. So let's press F2, text search, SMC clear FB error. We need to put here pointer to a drive inside. Okay, so address of axis 0, 1. Okay, that. Let's make some cosmetic changes. Let's put a comment here. Clear oldest FB error. Okay, we need to move it again. My mistake. Excellent programming. For this, best is to use this Boolean variable in our visualization and use some kind of a button. Okay, for that we go to visualization. We select the button. Let's put one button here. Properties. Text on the button. Clear FB error. Okay. Let's play a bit with the font. Okay, 10. Just to have it a little bit bigger. And now we need to input configuration, tap, and select a variable. In our PLC program, FB clear error. Okay, enter. Let's log in and test. So we will just execute MC stop, then MC reset, then again MC stop, then MC reset, and now if we clear, we see that we are clearing one by one. Okay, next, what is very nice is also to check the state. And there are two states which are communication state, and second one is axis state. Now, communication state, we can check with function block called SMC check axis communication. So let's create this instance of this function block. SMC check axis communication of axis 01 F2 SMC check axis communication. Okay, and now we can go to our motion FBs, and because this is checking the state of communication, we will run this function block before our condition is communication already running for the axis, which makes perfect sense. F2 instance call check axis communication. Again, let's move it to a line. For axis, we put axis 01. Let's make a short comment. Communication state. Here we will put FC and FB's call. Maybe motion. And now we have our state, and output, which is very interesting, is ecom state, which we will use in our visualization. So let's go here. Let's take this drive error, Control C, Control V. In other terms, copy paste, and let's change some text. So com state 2 dots %s, and we can now load and see what is going to be our state. Let's download. And it's not working. It's not working because we didn't change the variable. So now we need to change the variable. We'll go to application, PLC, checks axis state. and we will use ecom state. Okay, let's log in. SMC com state not started. One more thing. Let's log out. So we need to put here true to start. Log in. Okay, let's run. And if we go to visualization, initialization done, operational. So here we saw it. Let's do it one more time. Reset warm. Yes. And you see com state not started, initialization, waiting for synchronization, initialization done, operational. Excellent. Another state that we want to present is axis state. If we go to axis, we want to log in for this. And here we have status of our axis, which is power off. So we want to see how the state is changing. Out, visualization, another text box, let's copy paste this one and change text. We should call it axis state, also %n, and text variable is axis 01 dot n axis state. Let's log in. And we see here it's power off. Let's simulate. Here it stands still. If we, for example, move it, see what will happen. Continuous motion. If we stop, stopping, standstill. Now let's cover one more and the last topic for today. And it's one function block which provides you a little bit more data. This function block is called MC status. If we go to our PLC program, we log out. And let's go MC read status axis 01 MC, or let's hit F2, MC read status. Let's call it F2 instance call read status. As you can see, it has a lot of outputs. What we will put is axis 01, copy, paste, and we will enable it. Let's prepare a visualization. We are starting to run out of space. So let's move this here. Also, let's put it here, and our blocks to the left. We go to basic toolbox, again frame, drag and drop, MC read status. As you can see, it's a bit bigger. Let's call the reference of this function block. And that's it. For one additional thing, let's just put here text that we know. It's our axis 0, 1 on left bottom. This is good. Font black 18. Excellent. And we have more or less everything. Let's log in. Let's run. We have our stage changing for visualization, and immediately we already see when he is an operational, read status start to work, and here we can now, for example, enable a drive. So we see standstill or whatever is at the moment available. If we again try to run, what will happen? Okay, if we stop, for example, we'll see that it's stopping, and then it's in a standstill. If we reset, we see there is a FB error occurred. It's clear. That's it for today's video. In next video, we continue with certain movements, relative, absolute. If you like it, please give it a thumbs up and don't forget to subscribe. Bye.